Okay, guys, for this one, we're going to simplify the square root of 10 over the square root of 3. Now, as you can see, this one's a fraction, and this one has a little bit of a different routine that we're going to do to solve it. So this is called the quotient property of a square root. And for this one, we have to make sure that it's in simplest form. Now, a fraction containing radicals is not in simplest form until no prime factors appear under the radical sign with an exponent greater than 1, and if no radicals are left in the denominator. Now for this one you can see that there's no exponents whatsoever, so we're good on that. However, you do see that we have a radical in the denominator, and that is the square root of 3. So we have to get rid of that. And in order to do that, we have to use something called rationalizing the denominator. Now, to rationalize the denominator is a method that we use to eliminate the radical sign from the denominator of a fraction. And it's very simple to use. Rationalizing the denominator is by multiplying the denominator and the numerator by what the denominator's value is. So for example, since the denominator here is the square root of 3, we're going to go ahead and multiply the denominator by the square root of 3. The reason we're doing this is because the square root of 3 times the square root of 3 is going to give us the square root of 3 squared. And as you know, the square will cancel out the square root and just give us a 3. So now we've effectively gotten rid of the radical sign. However, we're not done yet, not even really close, because we still have to make sure that whatever we multiply the denominator by, we have to do the same to the numerator. So we have to multiply the square root of 10 by the square root of 3. And that's going to give us the square root of 30. So this looks like it could be our answer, but there's one more step in order to make sure that this is completely simplified. And that is we need to make sure that the prime factorization of the radicand is, in this case, 30. We have to make sure that it does not have the same prime numbers that repeat, because if it does, then we can go ahead and bring them outside of the radical sign. So let's go ahead and do the prime factorization of 30 real quick. This step should not take that long. So 10, we got 2, 5. Okay, and as you can see here, the prime factorization of 30 is 2 times 3 times 5. No number repeats by itself more than once, so this is our final answer. Okay, for this problem we have the square root of 2 over the square root of 6. So once again we're going to use rationalizing the denominator. So we're going to multiply the denominator by the square root of 6 and also the numerator by the square root of 6. So the square root of 6 times the square root of 6 in the denominator is going to give me the square root of 6 squared, which is going to equal 6. Now for the numerator, the square root of 2 times the square root of 6 is going to give me the square root of 12. Alright, so this appears to be our answer, but once again, like I said before, we got to make sure that your numerator, which is the square root of 12, does not have any prime factors that are the same, because if there is, then we have to go ahead and take them out of there. So let's go ahead and do the prime factorization of 12, which is 6 and 2, and 2 and 3. Okay, so we have a little bit of a different story here. We do have two numbers that are the same, two prime factors, which are 2. So now what we have to do is we know that the 2's are going to be put together, and it's going to be the square root of 2 squared, which is going to be 2. So let's go ahead and actually do that right now. Square root of 2 squared times the square root of 3 over 6. And this is going to equal 2 to the square root of 3 over 6. Now, this is not your answer, and let me tell you why. It can still be simplified. You can't simplify anything with the square root of 3. However, if you had, let's pretend that I took away this square root of 3 for a little bit. If you had a fraction that was 2 over 6, what would you do to simplify it? Could you simplify it? Of course you could. You would divide the numerator and the denominator by 2 to get 1/3. So that's essentially what we're going to do here. So I'm going to go ahead and put this back. And we're going to go ahead and divide each side by 2. Since there's 2 square roots of 3, if we divide by 2, it'll leave me 1 square root of 3. And 6 divided by 2 is going to give me 3. And that is my answer. It is totally simplified. Okay, here we're going to do our last problem, which it's asking us to simplify 2 over 6 minus square root of 3. Now for this one, we're still going to use rationalizing the denominator. However, we're going to use a different kind of rationalizing the denominator, and we're going to use something called conjugates to rationalize the denominator. Now for those of you that don't know what conjugates are, in previous lessons we had learned a form of an equation that was a minus b times a plus b, and that equaled a minus b squared. So this is pretty much the same thing we're doing here. So as you can see, we already have our negative here as your denominator. So I'm going to go ahead and multiply it by itself, but instead of doing it by a negative, I'm going to do it by the positive because that's going to give me what I need to know. So let's go ahead and multiply these. We got 6 times 6, which is going to give me 6 squared. And then we got negative square root of 3 times a positive square root of 3, which is going to give me negative square root 3 squared. And that's going to be what I have on the bottom so far. But remember that whatever we do to the denominator, we also have to do to numerator. So let's go ahead and multiply 2 by 6 plus the square root of 3. Now, if we go ahead and use distributive property to solve this, we know that 2 times 6 is 12. And 2 times the square root of 3, we're actually just going to leave it that way. We're going to leave it 2 the square root of 3 because we have 2 square roots of 3. Now let's go ahead and simplify this a little further. As you know with our denominator, 6 squared is 36. And negative is going to stay there. The square root of 3 squared is 3. So we're going to go ahead and put that right there. So we have 36 minus 3 on the bottom. On the top we have 12. It's going to stay the same. Plus 2 square root of 3. So the reason we're not changing anything here is because this 2 is not to be added to the 12 because this 2 symbolizes that we have 2 square roots of 3. We do not add it to that because if we were multiplying, it would be a different story. But since we're adding it, it goes ahead and stays that way. There's nothing else I could simplify on the numerator side, but the denominator I can still simplify something else. So let's go ahead and write the numerator. And my denominator, 36 minus 3 is 33. And that's as far as I can go with this problem. This is my simplified answer for this one. So remember that when you're adding, you cannot just add this 2. This 2 is there because it tells you how many square roots of 3 you have, not to be added to a whole number like 12.